Hi, everyone, and welcome to my class. My name is Joanna Earthlight, and this is Miss Earthlight Middle School Science. Today, the topic that we will be discussing is matter, mass, and volume. Now, these are the vocabulary words for this topic, and there's also a cool rap video that I uploaded, link in the description box below, and it's about mass, matter, and volume. So go ahead and check that out. Now for today's lesson, we have some essential questions that you need to be able to answer. But before we get to those, I wanted to ask you that if you like my videos or if you find them helpful, can you please subscribe to my channel and, like, share, and comment. If you have any questions or comments, I will gladly respond to those. Just put them in the description box below. Now for the essential questions that we need to be able to answer by the end of this lesson. How do scientists define matter? What is mass? What is the basic SI unit of mass? And the SI there means System International. It's just basically the metric system that they're talking about. So what's the basic SI unit for mass? What does volume measure? And we're going to look at two different units that might be used to measure volume. Then at the end, we want to explain how to find the volume of a regular shaped object and also how to find the volume of an irregular shaped object using the displacement method. All these we will be doing in our lesson today. Now, let's begin. So what is matter? Matter is defined by two things, right? So scientists define matter using two things, mass and volume. So matter is defined as anything that has mass and volume. What is matter, class? Very good. Anything that has mass and volume. And as you can see there on our screen, we have a triple beam balance that is used to measure mass and a graduated cylinder that we use to measure volume. Now, matter is everywhere and it's everything around us. So everything is matter. Whether it's our cups, our plates, or shoes, everything is considered to be matter. The birds, the bees, the trees, your family member, your mom and dad, everything, sister, brother, uncle, aunt, everything in the universe. Once it has a mass and a volume, it is considered to be matter. Good? So let's come to that. So since we realize that everything is matter and we know that matter is made up of both mass and volume, let us talk a little bit more about mass. Mass is the amount of matter in an object. What does that mean? It's the amount of unit of matter that makes up that object. And they measure mass with, as we say, the instrument is called a triple beam balance, as we can see here. It has 1, 2, 3 beams. That is why it's called a triple beam balance. And also they have the electronic balances as well. Right? Just to help us understand what mass is a little bit more, I am looking here at some rice. So let us say this is 1 gram of rice. So if you look closely, you'll see, if you look closely, you'll see that this gram of rice is made up of a lot of different grains of rice. So you could consider each grain of rice as a unit that makes up the total gram of rice. So that's what gives it its mass. All of the matter, all of the units of matter, in this case, all of the grains will make up the total mass of the object. And it's the same thing when it comes to a human being. All the cells or all the different units in the body makes up the body. And that's what's happening with everything that has a mass or takes up space. So everything is matter, right? And everything has a mass. So this 1 gram of rice is made up of all these individual grains of rice. So I hope that helps you to understand what mass is talking about. Now, people always confuse mass and weight. Mass, basically, as we said just now, is the amount of unit of matter that makes up the object, while weight is simply just the force of gravity pulling down on the object. You can see there the Garfield is standing on the scale, and his weight is pulling down based on gravity's pull. It will tell him a reading right there, right? So mass, just for us to get some clarity again, mass is the amount of matter in the object, and weight is gravity pulling down on the object. Now, let's talk about mass and weight as it relates to their location. So, because we know, or we should know, that in space there's no gravity, that is why when the astronauts travel in space, they fly around, they float around, right? They don't have no gravity. So that's one thing you have to consider now before we talk about the location. On Earth, everybody's standing on Earth because there's gravity pulling us down on Earth. So when you think about on Earth, you know that we will have mass because we have unit that makes up everyone's body. And we also have weight because we have gravity pulling people down on Earth. So mass and weight, you will have that if you're on Earth. It's not constant because at different places on Earth, you'll have different strength or different force of gravity pulling. For example, on Mount Everest, you'll have less gravity pulling than if you were at sea level, right? So that's kind of the difference there as it relates to mass and weight. Also, I want you to remember, mass and weight are directly proportional to each other, which means that the more mass you have, the more weight a person will have, right? So the more mass, the more weight. So just think of it that if you have the more mass something, right, the heavier it is, then the more weight it will have, basically. All right, so that's on Earth. What about space? Let's talk about space now. In space, as we said, the astronauts will be flying around. They'll be flying around, and because they're floating around, because there's no gravity to pull them down on anything, right? Or some books will tell you that there's a tiny bit amount of gravity, but it's not as much as what's on Earth. So, therefore, when you're in space, your mass does not change. You're the same mass, you're the same size, right? So the mass does not change. But in space, you don't have any weight, right? So as it relates to location, let's put it all together as it relates to location. In space, you have the same mass as you would on Earth. But in space, you have no weight. You're weightless. While on Earth, you have your weight because gravity is pulling you down. So that's just basically to talk about mass and weight as it relates to your location. All right, so let's look further now at volume. If we look inside this box, we would say those cubes, those green and orange and red cubes, they are filling up the space inside the box. What is that saying to you? So the cubes are taking up all the space inside the box. That's the volume of the box. So volume, guys, is basically the amount of space an object takes up. Let me repeat that. Volume is the amount of space that an object takes up. And we measure volume using cubic meters or cubic centimeters, right? And for some liquid, it's different. You'll have milliliters and liters to measure volume. So we have two different types of SI unit that we use to measure volume. It could be cubic meters, which is also the smaller form is centimeters. And also we have liters. The smaller form of liters is milliliters. Right? So you could say, if you get a question like that, you could say cubic meters and liters. You will still be correct. Okay, so volume, before we move on, is the amount of space that the object takes up. In this case, the space, the green and the red and the orange cubes are taking up the space in this box. So how do you calculate the volume of something? Because scientists love to calculate. Guys, do not separate science and math, because a lot of math is in our science. We're going to look at some right now. By how do we calculate the volume of a regular shaped object? These three things that you have to remember. When you look at the box, you'll see its length. You also see its width and its height. So in order to calculate the volume of a regular shape, like a cube in this case, you have to measure the length, the width, and the height of that cube. If you look at our box right here, we'll see that the length is 6 centimeters, the width is 3 centimeters, and the height is 4 centimeters. Right? And let us look at that. So we have the length times the width times the height. And in this case, it's 6 centimeters times 3 centimeters times 4 centimeters. If you were to calculate 6 times 3 times 4, you should get an answer of 72 centimeters cube. Now, what does this centimeters cube? Where does this 3 comes from? It's coming from us multiplying the centimeters 3 times. Centimeters times centimeters times centimeters will give us centimeters cube, or cubic centimeters that some people like to call it, right? So that is simply how you calculate the volume of a regular shaped object. And like I said, I will link in the description below on some cool experiments that you could look at that is doing these, in 3D, because we're just explaining it. All right, so for our next experiment, we're going to look at the volume of an irregular shape object. Now, if you look at the top of this graduated cylinder here, you'll find that there's a rock there. There's a rock at the top. So the rock in this case does not have a definite shape. It's an irregular shape, right? So we're going to use this special method called the displacement method. What is it called? I just want to highlight that for you. It's called the displacement method. And displacement means to move. So when you hear about movement, you could think about something being displaced. In this case, we're going to look at the displacement of the water that's inside the measuring cylinder, right? Or the graduated cylinder. So inside this graduated cylinder, the scientist placed 30 milliliters of water. How much? 30. It's right here. He placed 30. Let me see if I could do my drawing too. Yes, so they put 30 milliliters of water inside the graduated cylinder. Here it is. right? So that's your 30. So if you're going to do this experiment, the first thing you need to do is to write that down in your notebook. Write the 30 down and put first measurement beside it. Then they will put the rock inside of the water. So they will put the rock inside, and be careful if you're doing this with a glass graduated cylinder. Some people will tie a string to the rock and lower it gently inside the graduated cylinder. And then after that, then they will take the reading again. See, now it is at 35 milliliters, right? So 30, and then now after the rock is placed inside, it's 35 milliliters, right? So what will happen here is the students in the lab, or the scientists now, will have to calculate. And it's simple. Just subtract the 30, which is the first measurement, from the 35, which is the second measurement. So basically, you're going to subtract the smaller one from the bigger one. So in this case, you subtract 30 milliliters, and you take it away from the 35 milliliters, right? So 35 milliliters subtract 30 milliliters will give you 5 ml, right? So you end up with 5 milliliters. So the volume of your rock is 5 milliliters, right? And basically, because the water was displaced by 5 milliliters. So that is where the displacement method comes from. And I want you also to note, guys, that in finding volume, 1 milliliter is the same thing as 1 centimeters cube. You cannot leave off this small 3. So 1 milliliter is the same thing as 1 centimeters cube. And that is how you find the volume of an irregular shaped object. And you could go ahead and test it out in the lab with your teacher, guys, or on your own at home with a measuring cup. These are simple labs that should not be dangerous. Right? And if you like what I'm sharing so far, guys, please subscribe to my channel, like, share, comment, ask me any questions you like, and I'll be happy to answer them for you. Now, let's look at the review questions before I go. How do scientists define matter? It's your turn. Good job. Very good. Matter is anything that has a mass and a volume. Very good. Next question. What is mass? Good job. Mass is the amount of matter in an object. Very good. Next question. What is the basic SI unit of mass? Very good. Good job. The basic SI unit for mass is kilograms, or for smaller units, you could say grams for smaller objects. So kilograms are usually, because we know kilo mean 1,000, so kilograms are for the larger objects and grams are for the smaller object. But that's basically the same unit. And the next question, what does volume measure? Anyone remember? I'm listening. Very good. Volume is the amount of space an object takes up. Very good. For question number 5, what is the unit used to measure volume? And remember, there are 2 units. We have cubic meters or centimeters, right? So cubic meters or cubic centimeters. And also, guys, please remember we have liters or milliliters. And for our final 2 questions, explain how we find the volume of a regular shaped object. How do we find that volume, guys? Very good. We simply multiply the length times the width times the height to find the volume of that regular shaped object. Very good. And for our final questions, guys, explain how to use the displacement method to find the volume of an irregularly shaped object. I'm waiting. Good job. Very good. So first, you measure some water in a graduated cylinder or measuring cup. You record the measurement as first measurement. Then you place an irregular shaped object inside the water, which whether it's a rock or anything that you want to measure. Then you can record the second measurement. That's after you place the rock inside. And then subtract the first measurement from the second measurement. And there you have your volume for an irregularly shaped object. Guys, you did very well today. And I want you to put your hand up and tap yourself on the back. You did very well, and I'm proud of you. So if this video was helpful to you or any of your classmates or friends, please like, share, comment, and subscribe to my channel. Thanks for watching. Have a great day.